Okay guys, so this is the completed paddle code. I just wanted to point out a couple of things. First of all, we have four properties: location, we have color, and then we have paddle width and paddle height. Actually, I would change this to just PW and PH. Like the code was shorter, but then you have to make a bunch of changes throughout the code. In any case, the paddle width and the paddle height, and then we're going to run just two functions, update and render. Function is real simple, and we're using this new function called lerp, and we simply say where are we going from, where are we going to, and then finally how much do you want to move in that direction. And so a couple of people had problems over here with this number. Instead of putting in a decimal, they put in a ratio that was actually greater than 2, and it really messed it up. So lerp wants a third parameter that's between 0 and 1. If you put something greater than 1, it'll accept it, and it will just mess up your program. And then finally we have a rectangle. We have the location, the X location, the Y location, and then we have paddle width and paddle height. So that's the rendering the paddle. And I don't know why the fill color is green down here. That doesn't make any sense. In any case, that is our paddle function. So I think I'll take that line of code out. I don't know why that was there. So that's it. And now let's go ahead and take a look at the ball function. Okay, one of the critical things we have to pay attention to in looking at these constructor functions is that we are having trouble, some of us are having trouble matching the parameters. So inside the parenthesis, I am receiving 4 parameters, and you need to know what these parameters are. The first parameter says location, but it is a vector. If I ask you what something is, I want you to know that this thing is a vector. So if we look back at the sketch function, or the sketch. Okay, so here in the sketch file we see that we have 4 global variables, then we have setup, and when we load balls, we have first of all we load the paddle, and it has 1, 2, 3, 4, 5 parameters. So we're going to take a closer look at that in a little bit. But right now let's go ahead and look at load balls. So I call the function load balls, and I have this global variable called numBalls. So we're going to start off the program with 3, and every time I use up all the balls to go to the next level, I just call this function again, and I use a larger number for numBalls. So first it's 3, then it's 6, then it's 9, and so forth. In any case, I'm creating lines 57, 58. Oops, you can't see the lines. Let me move this over a bit. There we go. So on lines 57, 58, and 59, I'm creating a variable for the location, and so I get a random X, a random Y, and then I go ahead and create loc, and I have a dx and a dy. That's for speed, and so that's going to give me the 2 parameters here to create a new vector. I'm going to call that vel for velocity. Diameter is just here 20. I get a random X, RG, and B values. These are going to be very bright colors from 100 to 255, and then finally I pass in all these things as parameters when I make a new ball. And you know what? We haven't used push this year. I don't know why I put push here. So let's go ahead and say balls I. This is going to do exactly the same thing, but I'm going to say balls I is equal to, and I'm going to say ball. It does the same thing. Okay? So balls I is equal to ball. That will in effect do the same thing. There is an array function called push, but we're not going to use that. We'll just go ahead and say balls I equals ball. It will do the same thing. Okay, so that's how we are going to create all of our balls. But at the end of this, if I were to do a log function down here and say, hey, what is balls? It would show up in the console, and balls is going to be an array, and whatever number numBalls is, it's going to be an array of that number. So it'll start off with 3. So if I did this the first time, it would just give me an array of 3 balls. Okay, now we're going to look at a very important function in the ball constructor function. And that is a function called isColliding. isColliding is a function that is going to return true if there's a collision and return false if there's not a collision. And actually by collision in this case, I should mention that we're not taking into account the thickness of the ball. Just for simplicity's sake, we just took the center of the ball. The location X and location Y are the location of the center of the ball. So if the center of the ball passes through the top of the paddle, then you're going to have one kind of reaction. If it passes through the bottom of the paddle, you have a different type. But in general, we need to know what a collision is. And so we have 4 conditions here. The first one says this. I'm in the ball constructor function, so this is the ball. So I take its X location, I say 4 things have to happen. The X location of the ball has to be to the right of the left edge of the paddle, and so that's paddle.loc.x. and all four of these statements have to be true for the whole thing to be true. So then we check this .loc.x, again, the x coordinate of the ball, and it has to be less than the right edge. So since the upper left corner of the rectangular paddle is where the x and y location are, its right edge is this paddle.loc.x plus paddle width. So if the x location of the ball is to the right of that, and to the left of the left edge of the paddle, to the right of the left edge of the paddle, to the left of the right edge of the paddle, if it's below the top of the paddle on line 43, and above the bottom edge of the paddle on line 44, if all four of those things are true, then we have a collision and return true. All this is going to say is, yes, there's a collision, so return true, and if all four of those things aren't true, then we return false. Now, where we're going to call that function is over from draw. So I'm back in the sketch file. I'm looking inside the draw function. And the first thing I'm going to do is paint a background on line 26, and I'm going to run the paddle on line 27. But now I need a for loop to traverse the balls array and run through each of the balls. The first thing I'm going to do is I'm going to say if balls I dot is colliding. So the function we just looked at is colliding is on line 30. And remember, it just returns true or false. So if it returns true, then I'm going to go into line 31. 31 through, I guess, 40 only get called if there's a collision. And if there's a collision, there's two things we have to pay attention to. Balls I dot velocity dot y is less than 0. So if we look at the velocity of the ball, specifically the y value of the velocity, if it's negative, that means it's less than 0. That means that it is heading up, and it's a bottom collision. Remember, the coordinate system on the canvas is at least the y coordinate is opposite of what you see in a math class. Y increases as it's moving down and decreases as it's moving up. So if I get a y velocity that's less than 0, that means the ball is moving up, which means it's a bottom collision. So I made a comment there on line 31 that says bottom collision. And then I'm going to say endgame equals true. Incidentally, I created a global variable called endgame, and that's right here on line 11. And I can start the game off by saying this guy is false. So you start the game off and say endgame is false. And then if I get a bottom collision, then endgame becomes true. Okay? And so now if I do have a collision and it's not a bottom collision, then it must be a top collision. And so then I use that method we talked about in class, that function we talked about called Splice. That's in the array constructor function. And so balls is an array. So I can go inside the array, and there's this method called Splice. Incidentally, I keep going back and forth between method and function. Essentially, I use those two terms in this class synonymously. So it's a function called Splice, or a method called Splice, and the two parameters tell me at what location I want to remove the ball. The thing I want to remove in the array is at location I, and how many things do I want to remove? I want to remove one ball. So if I have a top collision, I remove the ball from the array, and I increase the score by 1. Score plus plus. Then I need to check, before I break out of here, I need to check if the ball's dot length is 0. That means all the balls are gone. Then I increase numballs by 3. It used to be 3, now it would be 6, and then it would be 9, and then it would be 12, and so forth. And I just call load balls again, and I'm passing in numballs, but I think numballs is a global variable, so that doesn't make any sense. Yeah, numballs is a global variable, so I don't need to pass this guy in here. And that's all I need to do. So if I look down at numballs or load balls, I'm not even taking anything in here, so I don't know why I had that parameter in there. Probably from a different version of the program. In any case, that will cover the logic of the ball interacting with the paddle. The key thing is I need to check whether or not it was colliding. If it is colliding, I'm good to go. Okay, the last thing I'm going to do in here is change a couple of things. Now that I have this global variable called endgame, I'm just going to create a simple if statement. So I'm going to say if endgame. So endgame is either going to be true or false. So I don't have to say endgame equals true. It is either true or false. And so if it's false, I'm going to have different code. I'm not going to play the gate anymore. If it's not false, then it must be true, so I can just say else. And all the code that I've written in here to play the game is going to come in here. So I should put a little comment here and say end game. And if I have a little code here, this is going to be play game. And so I'm going to take all of this code that we use to play the game, and I'm going to take that out and put that in here. And you know what? I just realized that this one line of code is for running the balls. I can put that right here. That would make more sense. And so now I'm going to get rid of that. I'm already traversing the arrays on line 33, so I don't need to do that again. And then this is the code for, you know, the text and all that kind of stuff. So that looks good. My curly brackets are right. I'm going to go ahead and format this one more time. And so now if game over equals true, and that means that I have a bottom collision on line 37, then when I come in here, what do I want to do? And I'm just going to not play the game anymore. I think what I'll do is I'll have some different kind of text. I'll just borrow this code and I'll put it in here. And instead of saying score equals, I'm just gonna print the score at the final screen. So in the last version of this that I did in class, we actually had a function called ending message, and we had a series of if-else statements, so that if the score was less than 3, you got a bad message like, wow, you're not very good at this game, your score was this. I'm going to leave that out of this video, but we could have just a call to create a string here where the string or the message at the ending screen depended upon what the score was. And I think that makes the game a little bit interesting, but that seems pretty simple. So I'm going to leave it there. That's it for tonight.